Every summer, the same ritual plays out in tens of millions of American homes. The thermostat creeps up, the air conditioner kicks on, and for the next 3 to 4 months, your electric meter spins like a slot machine that never pays out. The average American household spends somewhere between $492 and $719 just on cooling costs every summer. Air conditioning accounts for 12% of total home energy expenditures nationally, and if you live in the Southeast, where the air feels like breathing through a hot, wet towel, that number climbs to 27%. We have accepted this as the cost of comfort. But what if someone told you that a simple copper coil setup, built from parts at your local hardware store for about $15, could begin to change that equation entirely? And what if the reason you have never heard about the more advanced version of this technology has less to do with physics and more to do with who profits when you keep paying $300 a month to stay cool? Let us start with what this thing actually is, because the build is so simple, it almost feels like it should not work. You take copper tubing and coil it around a standard box fan. You connect that tubing to a small aquarium pump, the kind you would use in a fish tank, and you circulate cold water through the coils. That is it. The total materials cost runs between $15 and $30, depending on what you already have lying around. But the reason copper is the material of choice here is not arbitrary. Copper has a thermal conductivity of 401 watts per meter Kelvin. That is nearly twice the conductivity of aluminum, which sits at 235, and 7 times faster than steel. The only metal that beats copper is silver, at 429 watts per meter Kelvin, but silver costs roughly 50 times more. Copper sits at the exact sweet spot of thermal performance and affordability. When the fan blows room air across those cold coils, heat transfers from the air into the copper, from the copper into the water, and the air coming out the other side drops 8 to 15 degrees Fahrenheit. You can feel it immediately. It is not theoretical. It is not a gimmick. It is thermodynamics doing exactly what thermodynamics does. Now, the version that goes viral every summer on social media is what we will call Level 1. You fill a cooler with ice water, drop in the aquarium pump, and circulate that ice water through the copper coils wrapped around a fan. It is cheap, it is fast, and it works immediately out of materials from any hardware store. This setup produces roughly 100 to 1,200 British thermal units of cooling, depending on the ice volume and flow rate. For context, a small window air conditioning unit produces 5,000 British thermal units. So the ice version is cooling a personal zone, the area directly in front of the fan, not a whole room, and certainly not a whole house. The ice melts in 1 to 4 hours and requires constant refilling. And here is the part most viral videos conveniently leave out. Your freezer used electricity to make that ice in the first place. You are not eliminating the energy cost. You are just moving where the cooling happens. That said, this version is genuinely excellent for specific situations. Emergency cooling during power outages, van life, off-grid camping, keeping comfortable while you sleep. It has real, legitimate uses. But it is not a whole house solution, and anyone telling you otherwise is selling you a fantasy. Here is where it gets real. Below the frost line, typically 4 to 6 feet deep depending on where you live, the Earth maintains a remarkably stable temperature of 55 to 65 degrees Fahrenheit year-round. It does not matter if the surface is baking at 110 degrees in July or frozen solid in January. Down at that depth, the ground stays cool and constant. The Level 2 version of this system buries 200 to 400 feet of coiled copper or high-density polyethylene pipe underground in trenches and circulates water through that buried loop. The ground absorbs heat from the warm water, and cool water returns to a heat exchanger mounted indoors. This is the same fundamental principle behind professional geothermal heat pump systems that cost $15,000 to $30,000 fully installed. The DIY version strips it down to the bare essentials: no compressor, no refrigerant, no complex mechanical systems. Just pipe in the ground, a pump, and a fan coil unit inside your house. Earth pipe cooling is a proven passive technology that has been studied extensively. Research confirms that soil at 1.5 to 2 meters depth maintains stable temperatures capable of pre-cooling air without any compressor or chemical refrigerant. This is not fringe science. This is geology and thermodynamics working together the way they have for billions of years. To understand why ground source cooling is so effective, you have to understand why traditional air conditioning is fundamentally fighting a losing battle. Your air conditioning unit works by absorbing heat from inside your home and dumping it outside through a condenser. But on the hottest days, when you need cooling the most, outdoor temperatures reach 95 to 110 degrees Fahrenheit. Your condenser is trying to reject heat into air that is already brutally hot. The hotter it gets outside, the harder your air conditioning has to work, and the more electricity it consumes. Efficiency drops right when demand peaks. It is an engineering problem baked into the design. Ground source systems sidestep this entirely. Instead of dumping heat into 100-degree air, you are dumping it into 55-degree earth. The temperature differential is always favorable, regardless of what the weather is doing on the surface. Professional geothermal heat pumps achieve energy efficiency ratings of 15 to 25, compared to conventional air conditioning ratings of 9 to 15. Geothermal systems use 25 to 70% less electricity than standard air conditioning. And during heat waves, when conventional air conditioning systems are straining and failing across entire grid regions, ground source performance stays rock solid because the ground temperature simply does not change. The Earth does not care about your heat wave. So why are we not hearing more about this? Why is every home in America not sitting on top of a ground loop? Follow the money. Air conditioning is the golden goose for electric utilities. Cooling drives 30 to 50% of summer electricity usage in homes. More importantly, cooling demand creates the peak loads that justify building expensive new power plants and transmission lines. This is critical to understand. Utilities in most of the country operate under a rate of return model, which means they earn a guaranteed profit on capital investments. The more infrastructure they build, the more they earn. Every new power plant, every new transmission line, every substation upgrade that gets justified by summer peak demand puts money in their pockets for decades. If homeowners slash cooling costs by 50 to 70%, utilities do not just lose revenue from the electricity you did not buy. They lose the justification for building the infrastructure they were planning to bill you for over the next 30 years. Utilities do not really sell energy. They sell infrastructure. And every kilowatt you do not use is a power plant they cannot justify building and billing you for. We have already watched this exact pattern play out with rooftop solar. As solar adoption grew and customers started generating their own electricity, utilities did not just accept the lost revenue. They fought back. In 2024, 47 states took policy action on distributed solar, and utilities responded by pushing fixed charges, unavoidable monthly fees, designed to recoup revenue from customers who had the audacity to use less electricity. California utilities now charge $24 per month in mandatory fixed fees, regardless of how much energy you use. Arizona charges solar customers a specific grid access charge, a fee that exists for no other reason than to punish customers who reduced their consumption. The Colorado Energy Office acknowledged publicly that if more households adopt geothermal cooling, utilities could skip building new transmission infrastructure. Less infrastructure means less capital investment, and less capital investment means less profit under the model utilities operate on. That is not a conspiracy theory. That is their own regulators saying it out loud. Now, let us be honest about the limitations, because intellectual honesty matters more than virality. The $15 ice and fan version is real and it works, but it provides personal zone cooling only. It is not replacing your central air. The ground loop version genuinely works as a whole house cooling strategy, but the real cost is not $15. A proper do-it-yourself ground source system runs $500 to $2,000 in materials, including pipe, a circulation pump, a fan coil unit, and trenching labor or equipment rental. That is still a fraction of the $15,000 to $30,000 for a professional geothermal installation, but it is not pocket change, and it is not a weekend project. Soil type matters enormously. Sandy, dry soil conducts heat poorly, which means the ground around your pipes will not absorb heat efficiently. Wet clay soil is ideal. Your local groundwater table is a huge variable. If groundwater flows near your buried loop, it carries away absorbed heat naturally, dramatically improving performance. If your soil is bone dry, performance drops. And sizing the loop wrong means the ground around the pipes saturates with heat over the course of a summer and gradually stops absorbing. You end up with warm water circulating through warm ground, and your system effectively stops working. You also still need electricity to run the circulation pump and fan, so this is low-energy cooling, not zero-energy cooling. These are solvable problems, but they are real problems, and pretending they do not exist helps no one. The bigger picture is this. The Department of Energy offers a 30% federal tax credit for geothermal heat pump installations, which brings that $15,000 to $30,000 professional system cost down significantly. But the real disruption here is not one $15 copper coil wrapped around a box fan. The real disruption is millions of homeowners arriving at a realization that changes their relationship with their utility company forever. You do not need a $300 a month summer electric bill. The ground beneath your house is a free, functionally infinite heat sink, and it makes the utility industry's most profitable seasonal product optional. Utility companies are not afraid of one person with a fan and some copper tubing. They are afraid of the idea. They are afraid of what happens when enough people understand that the same earth they are standing on can cool their homes for a fraction of the cost, using technology that has no moving compressor parts, no chemical refrigerants, no planned obsolescence, and no monthly bill that goes up every year. The earth has been sitting at 55 degrees beneath your feet since before Willis Carrier invented modern air conditioning in 1902, and it will stay that way long after the last compressor burns out. The only question is how long it takes before enough people stop paying a premium for something the ground has been offering for free all along.